Classmates, today we are going to introduce the routing protocol. First of all, students need to understand what routing means. Routing is the process of forwarding data packets across an interconnected network from a source host to a destination host. In the topology diagram below, data travels from the 10.120.2.0 network to the 172.16.1.0 network. In other words, from the PC on the left to the PC on the right, passing through multiple routers and multiple links. Routing helps the data choose the appropriate path to reach its destination smoothly. The device responsible for forwarding data packets to the correct destination and selecting the best path during the forwarding process is called a router. Now, let's take a look at how routers work. In the topology diagram, there are 4 PCS and 2 routers. Let's assume host 1.1 wants to send data to host 4.2. First, the data is sent from PC 1.1 to the router. The router receives the data and checks the destination address in the data packet, which is 4.2. It then looks up the routing table and finds that the corresponding port for the 4.0 network is mapped to S0. Router 1 forwards the data to the S0 port. At this point, the data is forwarded to the S0 port. Router 1 sends the data from the S0 port to Router 2's S0 port. Router 2 receives the data packet, checks the destination address, and looks up the routing table. The destination address 4.2 corresponds to an entry in the routing table for the 4.0 network, mapped to the E0 port. Router 2 forwards the data to the E0 port. And finally, host 4.2 receives the data packet. So, this process of data transmission from host 1.1 to host 4.2 is the working process of routers and the data forwarding process. In the aforementioned router working process, we used a routing table. The main function of a routing table is to maintain routing entries within the router, enabling the router to make path selections. Now, how is this table formed? The first method to obtain a routing table is through direct connection, which means obtaining routing entries via directly connected routes. When an port's IP address is configured on a router and the port is in an up state, the routing table will include entries for directly connected routes. In the topology diagram, the router's F0 zeroth port has an IP address of 192.168.1.124. So we learn from the direct connection that the routing table includes an entry for 192.168.1.024 mapped to port F0 zeroth. Similarly, the router's F0 first port has an IP address of 10.1.1.18. So we learn from the direct connection that the routing table includes an entry for 10.0.0.08 mapped to port F0 first. If there were an additional router in the topology diagram, representing another network segment, for example, 20.0.0.08, this router would require static or dynamic routing for non-directly connected network segments to add them to its routing table. What is a static routing? A static routing is a manually configured routing entry set by the network administrator and is unidirectional. For example, in the topology structure shown, to configure a static routing on router A, one would manually add a routing entry that says to reach the 192.168.1.0 network segment. Forward the data packet to router B's port with the IP address 192.168.2.1. Similar to static routing, there is another type of route called a default routing. When a router cannot find a routing entry for the destination network in its routing table, it forwards the request to the default routing port in the depicted topology structure. For router B, any non-local data packet will be forwarded to router A's port with the IP address 192.168.2.2. In real-life scenarios, which environments require the use of static routing, and which environments require the use of default routing. Static routing is generally used in small-scale networks with fixed topology structures. They have the characteristic of manually configured routing tables that do not change unless network administrators intervene. The formation of the routing table does not require using network resources. Default routing is typically applied in stub networks with only one exit point, or used as a supplement to other routes. Their characteristic is having the lowest priority among all route types. The above is the content of our class this time. Through learning, please complete the following assignment. Based on the content of this class, please compare the basic principles of routing and switching, and identify their similarities and differences.